Good morning students. Today we are going to start with next programming technique, that is modular programming. So in the previous lecture we have studied that there are two types of programming techniques, structured programming and modular programming. So in the previous lecture we have studied about structured programming. What was structured programming? When we have to execute all the blocks, or when we have to execute the program in a sequential way, in a proper way, and we cannot skip any of the steps. So that is structured programming. Now we have to start with the second approach of programming. So the name of the second approach is modular programming. Now what is modular programming and why we use modular programming? Modular programming is, in modular programming we can divide the large problem, or we can divide a large program into smaller sub programs. So as we can divide a large program into smaller sub programs or smaller modules, so it is easy for the programmer to work on small module as compared to on the whole program. So these are the advantages of modular programming, that it is easy to handle small module, it is easy to debug small module, it is easy to design small module, and even it is easy to test small module as compared to the when we have to apply all the techniques on a whole program. So these all are the advantages of modular programming over structured programming. So this is the reason why most of the programming languages support modular approach. So modular programming is the process of subdividing a computer program into separate programs, separate sub programs. So it means we can divide a large problem into smaller sub problems. So now what is module? A module is a separate software component. So each individual unit that we have divided is known as module, and we have to treat every module as independent unit. So it can often be used in a variety of applications and functions with other components of the system. Some programs might have thousands or millions of lines, and it is very complex to manage that programs, because it is very difficult, as there might be too many syntax errors, logical errors present in the program. So hence it is very easy if we follow modular approach to handle these problems. Modular programming emphasizes on breaking of large program into smaller problems to increase the maintainability, readability of the code. Maintainability means it is easy to maintain the code, as it is easy to debug the code, write the code and test the code. And readability is, it is easy for the user to understand a small module as compared to large module. So it increases the readability of the code, and it also makes the program handy to make any changes in future or to correct the errors. And if anyone or programmer has to make changes in a small module as compared to the large program, it is easy for the programmer to do that also. So this is modular programming. So students, every programming language is based on these two programming techniques. Some of the programming languages are based on the structured programming, and some are based on the modular programming. But if we talk about what is the best approach and what is the best method, so modular programming is the best approach to apply on any of the program. So many of the programming languages are now based on modular programming approach. Now next thing is, what are the advantages of modular programming? So easy to use. So as I have already discussed that if we have to apply all the things on a single module as compared to a large program, so it is easy to use. Reusability. Now this is one more advantage of modular programming, that is reusability. Reusability means, for example, we have a single module and we want to use that module at different locations for different purpose, so we can reuse a single module many times. So this is the one more advantage of modular programming, which we cannot use this advantage in structured programming. So in modular programming, it is very beneficial thing. We can use a single module anywhere, wherever we want, and number of times we can use it. So that is reusability. Next advantage is easy to maintain. Ease of maintenance, that is, it is easy to maintain. As we are working on, if we are working on a single module, it is very easy to maintain that module. Now maintain is like when we have to update the software, read the software, write the software, we have to make any changes in the software. So these all things are very easy if we have to perform it on a single module. So these all are the advantages of modular programming. So with this, students, we have completed this topic, that is programming techniques. So we have completed this topic, programming techniques, where we have studied two techniques, structured programming and modular programming. So it is very important for you to understand what is the basic difference between structured programming and modular programming. Now let's start with the next topic of this unit, that is searching. Now this is the next and the last topic of this unit, searching. So what is searching? Searching is one of the very main operation of data structure and of computer science, because it allows us to search for a specific item from the given data. So now what is searching? What are the ways that we can apply search on any of the given data? So in this section, we will study about searching and techniques of searching. So first of all, what is searching? Searching is the process of finding a given value position in a list of values. So searching is, for example, you have a list of data, or you have a list with 100 values, with 100 items, and if you want to search anything, you want to search any particular item, so what you have to do is you have to traverse the list. So for searching, you have to access and process the element in a list. And so if you have to search any particular item, so for this you have to access and process each element exactly once to get that particular item. So it depends upon the item that whether it is present in the list or not in the list. So result will be according to the presence of the item. So it can be successful search or unsuccessful search. So that is searching. So it decides whether a search key is present in the data or not. Now it is also the algorithmic process of finding a particular item in a collection of items. So see students, in the second unit I have explained you that what is algorithm and why we use algorithm. So similarly, if we have to apply searching in data structure or in terms of computer science, if we have to apply any of the searching technique, we must have to follow some algorithm, and different algorithms are available to apply the search on the given data. Even nowadays artificial intelligence area and machine learning, so these all techniques are based on the algorithms, because they have different algorithms and they apply these algorithms on the data to draw conclusions and to draw results. So this is how we have to perform searching. And what is searching? And we can apply searching in two ways. So the two ways of searching is linear search and binary search. So the very first searching technique is linear search. This is very simple technique. Now I will explain you what is linear search and what is binary search. So let's start with the first searching technique, linear search. So see students, as the name is linear, so linear means we have to search the item in a sequential way. We have to search the item in a particular way. We cannot skip any of the items. So that is sequential search. So we also call it linear search as sequential search. So Sequential search starts at the beginning of the list. We always have to start from the beginning of list. We cannot start from the mid of the list or any other item of from any other element of the list. We always have to start from the beginning of the list, and we have to check the every element of the list in sequential order. So that is linear search. So it is a very basic and simple algorithm. So the real life example of linear searches, for example, you have 10 items, you have placed 10 items in a queue and you have to search for a specific item. So the procedure is you have to start from the first element and you have to search every element exactly. You have to access and process each element exactly once, and then you have to move to the next element and so on. You have to repeat the process. So that is linear search. Now I have taken one example to explain you the concept of linear search. For example, we have a list of 6 numbers. So these are the elements in a list: 10, 5, 15, 20, 25 and 35. So these all are the elements that we have stored in an array data structure. This is array data structure. So for example, we want to search element 25. We want to check whether 25 element exists in the list or not. So what we have to do, what is the procedure? So your item that you have to search is 25. So first of all, you have to start from the very first element of the array. So the very first element of the array is 10. So what you have to do is you have to compare your item with this element, that is first element of the array. So your item is 25 and you have to compare it with the first element of the array, that is 10. 25 is not equivalent to 10. So it means search unsuccessful, item not matched. So what you have to do is you have to move to the next step. So after comparing with the first element, you have to move to the second element. So this is the second element. Now again you have to repeat the process. You have to compare 25 with the 5, item not found. So you have to move to the next step. So you have to repeat the process till the end of the list or until you find the given item. So now you are at third location. Your item is 25 and the element at third location is 15. 25 is not equivalent to 15. So it means item not found. So you have to move to the next step. So at this location the element is 20. So 25 is not equivalent to 25. 20 is not equivalent to 25. So again item not found. You have to move to the next location. Now your item is 25 and the element at that location is 25. 25 is equals to 25. So it means item match. So you have to write the location of this element, whatever is the location of the element. For example, according to this array, the location is 1, 2, 3, 4, 5. So the location is 5. So in the result, you have to write the location, that is 5, and you have to write search successful. So this is how you have to perform linear search. So students, in 11th standard, you have just a basic introduction of linear search and binary search. Now the next thing is we also have to study algorithms of linear search and binary search, but they are in 12th standard. So this is all that you have to study in 11th standard only, basic introduction of linear search. Now next is binary search. Now what is binary search and what is the difference between linear search and binary search? So see students, as in the linear search, we have to, whenever we have to search any element, we have to traverse the list in a sequential way. That is linear search. Now in binary search allows us facility that we do not have to traverse the whole list. So this is advantage of binary list, that we do not have to search the item in a sequential way. So binary search method is based on the mechanism that first of all we have to divide the list into two halves, that is left half and the right half. Now after dividing the list into two halves, we have to check the availability of item in the every half. So for this we have to compare our item with the elements of the list, and then we have to decide whether we have to move to the left of the list or right of the list, and we have to at the end we have to discard the one portion of the list. Now before starting with this binary search, I want to discuss one real life example of binary search. For example, when we use dictionary to search any particular word, so you know that in dictionary every word is in sorted form, that is they are arranged in alphabetical manner. So when you search any word by using dictionary, you cannot apply linear search on dictionary. So what you will do is you will open the dictionary to the middle, and then you will check that whether your alphabet will be in the left of the left part, or to the that word will be in the right portion. So for example, you have to search any word that starts from the S, and you have opened the dictionary from the word K. K. You are at right now you are at K alphabet, and you have to search your word which starts from the S alphabet. So you can simply, if you have opened your dictionary to the K alphabet, you can simply discard the left portion of the list, because S cannot exist in the left portion of the list. Then you can simply discard the left portion of the list, and you can move to the right portion of the list, and you have to repeat the process. So that is binary search. So see students, binary search have reduced the list to the half, and it has saved a lot of time. But the one main drawback of binary search is you cannot apply binary search on unsorted list. Unsorted list means if the list is not arranged in a particular order. So for example, look at this linear search example. This list is unsorted list. The element is 10, 5, 15, 20. They are not arranged in ascending or descending order. So if your elements are not arranged in any particular order, then you can apply linear search. But if you have to apply binary search, your list must be sorted. Your list must be arranged in ascending or descending order. So this is the reason the binary search is very costly method. Now why it is costly method? Because if we have to apply binary search on any of the list, so first we have to perform sorting algorithm on that list to arrange the elements in a sequential order, or to arrange the elements in ascending or descending order. So then after that we can apply binary search. No doubt binary search is very efficient algorithm. It is very fast algorithm as compared to linear search, but the only drawback is it is very costly algorithm, because we have to apply two things on binary search, that is sorting algorithm, as well as after that we have to apply searching techniques. So that is binary search. Now let's start with the definition of binary search. So binary search is the search technique which works efficiently on the sorted list. So this is the very first condition of the binary search, that is we can apply it we can apply binary search only on the sorted list. So hence, in order to search an element into some list by using binary search, we must ensure that the list is sorted. So if the list is unsorted, then we have to apply some sorting algorithm. Different sorting algorithms are available. It is up to the programmer that whatever he wants to choose. Now binary search follows divide and conquer approach. Now why it follows this approach? Because we have to divide the entire list into two halves, and we have to discard the one portion of the list. So that's why this is the name that we have given to this algorithm. So in this we have to divide the list into two halves, and item is compared with the middle element of the list. If the match is found, then the location of the middle element is returned. Otherwise we have to search either into the halves depending upon the result produced through the match. Now I want to show you this with the example. that how we have to apply binary search on any of the list. So for example, we have a list of 9 elements and we have stored all the elements in an array. So these all are the 9 elements, and in array, if the first element always starts with the 0 index value. So that is 0 to 8, and there are total 9 elements. So the elements are 20, 35, 37, 40 and so on. So see students, these all are in sorted order. So we can apply binary search on the given list. Now the first element is 20 and the last element is 67, and the middle of the list is index number 4 and the element at this location is 45. So this is the first, last and middle of the list. Now for example, we want to search 37 number. We want to search item 37. So what we have to do is, first of all, we have to compare our item with the middle of the list. So look at this middle of the list. Middle of the list is 45 and our item is 37. 37 is less than 45. So it means our item will be somewhere in the left of the list. It cannot be in the right of the 45 because 37 is less than 45. So in this, what we have to do is we have to discard the right portion of the mid. So we have to discard these 4 numbers and we have to consider this list as a new list with 5 numbers only. And then we have to check the availability of the 37. So this is the first step. The second step is, now our new list is the first element remains same, that is 20, but 45 becomes last element and 37 is middle element. Now we have to compare our item with the middle of the list. So our item was 37 and middle of the element is 37. So item match and search successful. So see students, in just 2 steps we have searched the particular item in the list, and this is how we have to deal with the binary search. Now there is one more example. I have taken a full-fledged example of binary search. So how we have to discard the list and how we have to move to the another portion of the list. So for example, we have a list with 10 elements. So the 10 elements are from 0 to 9 and these are the elements 2, 5, 8, 12, 16, 23, 38, 56, 72 and 91. For example, we want to search element 23. So the item that we have to search is 23. Now what we have to do is we have to calculate the mid of the list. So see students, there are basic formulas that we have to apply while calculating the mid of the list, but that part we will study in 12th standard because we have to study complete binary search algorithm in 12th standard. So here I am not discussing that how you have to calculate the mid of the list by applying the formula. So I am just giving you a basic description of this. So the mid of the list is index number 4. The element at that location is 16 and the item that we have to search is 23. Now we have to compare our item with the mid of the list. So the mid is 16 and the item is 23. 23 is greater than 16. So it means the item will be somewhere in the right of the list. It cannot be in the left of the list. So after the first step, we have to discard the left portion of the list. So we have to discard these 4 elements. Now let's move to second step. Now this is the starting point of the list. Now we have to calculate the new start of the list. So index number 4 is the new start of the list and index number 9 is the end of the list. End remains same in this case and we have to change the beginning of the list. Now again we have to calculate the mid. So the mid of this is 56, that is 7, index number 7 and the item is 56. Now we have to compare our item with this item. 23 is less than 56. 23 is less than 56. It means it will be somewhere in the left of the list So in that case, we have to discard the right portion of the list. So we have to discard this right portion of the list. Now this is the new list. So in this case, the beginning remains same. So the beginning is index number 5 and the item is this, and we have to change the end because we have discarded the right portion of the list. So this is the new end of the list, that is index number 7. Now we have only 3 elements in the list after discarding the remaining elements. So now we have only 3 elements. Now we have to calculate the mid of the list. So the mid is index number 6 and the item is 38. So we have to compare 23 with the 38. 23 is less than 38. So it means it will be somewhere in the left. So in that case, we have to discard the right portion of the list. So discard this one number 56 from the right, and we have to change the end. Now beginning is this index number 5 and end is this 38 and index number 6. Now in the final list we have only 2 elements, and the index number 5 is beginning, index number 6 is end. So there are only 2 elements in the list, and we have to calculate the mid. After calculating the mid is 5 and the item and this location is 23 and our item is 23. So we have found our item and search is successful. So we have to stop at this step. So this is how we have to perform binary search. So see students, you do not have to apply this example, or you do not have to solve this example. You can just, I have explained you this to explain so that you must have an idea that how we have to discard the list and how we have to deal with the remaining elements. So that's why I have showed you this diagram. You can take example of this diagram only to indicate the start of the list, end of the list, and the middle of the list, and you can take any element. So this is how you have to perform linear search and binary search. So with this students, we have completed this unit, and tomorrow we will start with the third unit of CS1, that is C++ programming. So in today's video we have studied linear search and binary search. So these both are very important topics, so you have to study these topics. So that's all for today.